right input, right quantity, right place, right time. So what exactly is needed and how much quantity is needed and where exactly is needed and when it is needed. So determining the variability occurring within the field and giving the treatments or interventions according to the exact need of the field, which is exactly what is known as precision farming. So to be more specific or more scientific, the definition may a little bit elaborated, like application of technologies and principles to manage the spatial and temporal variability associated with all aspects of horticultural production. So all of us know, suppose if you take a big field and if you are planning for a particular crop, so what exactly happens is now the traditional farming or conventional farming in which the entire field will be treated as a single piece of land. So without seeing in the variability occurring within the field, whether it is 5 cents, 5 acres or 50 acres, the entire field will be treated as a single piece of land and the uniform treatment will be warranted to the entire field. So that is what is conventional farming. But in precision farming, what exactly needed is you have to manage the spatial and temporal variability which are occurring in the field. So within the field variability. So actually, in precision farming, a single unit can be considered as an area of not exceeding 50 cents. So the strategy is divide the land into small micromanagement units of 50 cents or even less. So suppose you are having 5 acres of land. In conventional farming, you will be treating the 5 acres as a single piece of land and you will be giving uniform treatment. But in the case of precision agriculture, you will be dividing the land into small micromanagement units of 50 cents or even less. And if your land size is, if the unit size is 50 cents, that is the optimum size. And if you can go for a smaller size, it will be, the precision will be better or more precision or more accuracy can be obtained. So suppose if you are dividing into 50 cents, it will be 10 units. But if you are dividing into 25 cents, it will be 20 units. If you are dividing into 10 cents, it will be 50 units. So smaller the size, better will be the precision or accuracy. So divide the land into small management units. Then you have to have 3 things minimum essential for in precision agriculture. If you want to go for precision agriculture, the 3 essential things are complete information about the soil, then complete information about the water, then complete information about the crop. So these things are highly essential. So at every 50 cents, at least every 50 cents, you have to analyze the soil and complete information about the soil. So dividing into micromanagement units is not physically going into the field and taking a tape or a chain and dividing into 50 cents. It is exactly based upon within the field variability. So what one has to do is you have to move into the field, you have to make a reconnaissance survey, move along the field and see the markable variability within the field through your eyes. So just observe the field and see what are the notable variability existing within the field. Depending upon the notable variability existing within the field, you divide the land into small micromanagement units of 50 cents or even less. So maybe depending upon the type of soil, depth of soil, and then the nutrient status, moisture status. So depending upon the within the field variability, you have to go to the field and you have to identify the variability and you have to divide the land into small micromanagement units. Then whatever irrigation you are giving, so maybe you may be using different source for water. So maybe you may be using a well, you may be using a pond, you may be using river water, you may be using canal water. So wherever there is a change in the source of water, you have to analyze the water. And within at every 50 cents, at least you have to analyze the soil. Then you have to gather complete information about the crop. So crop information about the crop means it's not exactly you are collecting, because you are just gathering whatever information available about the crop based upon the published works. So maybe almost all the state agriculture universities or the national bodies, research centers, they might have published a package of practice recommendation for all the crops. So at least every 50 cents, you analyze the soil before the commencement of every cropping season, and from every source of water, you analyze the water again before the commencement of every cropping season, then gather complete information about the crop. So the soil parameters required are maybe the soil structure, depth of loose soil, which determines the root penetration of any crop. So soil structure, then depth of loose soil, then water holding capacity of the soil, which is directly related to the soil texture. Then available nitrogen, available phosphorus, available potash, available micronutrients, available organic matter content, then acidity or alkalinity of the soil represented by the soil pH, then soil salinity. So these are the 10 parameters. So you have to analyze these 10 parameters from at least every 50 cents. Then likewise, You gather the water samples from every source before commencement of every cropping season. Then the minimum 4 parameters which are highly essential is, one is water hardness. So what that represents the water quality. Then the dissolved chemical constituents of water. No water from any source will be as pure as distilled water. It may contain some minerals dissolved in it. So the dissolved chemical constituents of the soil. Then again, pH or acidity or alkalinity of the water. Water pH plus the salinity of water. These parameters. Then again, you have to gather all the information pertaining to the crops, just like crop to crop spacing, row to row spacing, daily water requirement of the crop, total duration of the crop in days, and total nutrient requirement of the crop. So out of these 5 parameters, the first 3 parameters are essential for the design of micro irrigation. For example, the crop to crop spacing decides the emitter spacing of micro irrigation. Then row to row spacing that decides the lateral spacing of micro irrigation system. Then daily water requirement in liters that determines the number of emitters and discharge capacity of each emitter. So likewise, total duration of the crop and total nutrient requirement throughout the growing season, that determines the fertigation scheduling. Fertigation scheduling means nothing but determination of the quantity and timing of application. So for micro irrigation design, you need crop to crop spacing, row to row spacing, and daily water requirement. And for fertigation scheduling, you need total duration of the crop and total nutrient requirement. So after gathering all these informations, an expert in the field of agriculture, in the field of precision farming, he gives a package of practice to the entrepreneur, to the farmer, which is known as precision farming, which is also referred to as high-tech farming, which is also referred to as variable rate application farming. Instead of giving uniform application throughout the field, you are giving at varying rates. Or it's also referred to as site-specific farming, or again, once again, it's referred to as prescription farming. Prescription means just like a doctor examines a patient physically, then he asks the patient to undergo some laboratory test. Then after going through the laboratory test results and the physical, and after based upon the physical examination of the doctor and the test report, the doctor gives prescription to a patient. Just like that, after going through the soil test results, water analysis results, and the crop parameters, then expert that gives a prescription to the farmer, which is the prescription farming, which is also referred to as high-tech farming or precision farming. Now, the major difference between precision agriculture and conventional agriculture is in the level of management. As I already told, in conventional farming, the entire field is treated as a single piece or single piece land management strategy. Irrespective of the size of the land holding, you are simply considering it as a single unit and uniform treatment is given throughout the field. Whereas in precision agriculture, you are dividing the land into small micromanagement units of 50 cents or even less. Now, if you consider that, or if you imagine that precision farming as a triangle, the 3 sides of the triangle, which are the key aspects of precision farming, which are information, technology, and management. So it's also referred to as technology-enabled, information-based, and decision-focused method of farming. So you are utilizing all the available information and you are utilizing all the possible technologies, and you are having a focused decision, and your decision is like optimal yield of the crop that you are planting. So there is a single point of focused decision in precision agriculture, that after utilizing all the information, all the possible technology, and imparting all the possible scientific management strategies, you are aiming at the optimal yield. So this is a decision focused method of farming. Now, this is also referred to as a modern eco-friendly technology. Precision agriculture is also referred to as a modern eco-friendly technology because of 2 reasons. First one, it reduces stress on natural resources. Second one, it leads to total quality management. So reduces stress on natural resources means if you are going for precision agriculture, definitely that reduces stress on the 2 vital natural resources called soil and water. All of us know the 2 major natural resources which are used for agriculture is soil, then water. So what happens is in conventional farming, you are just filling the, using the conventional water wasting surface methods of irrigation simply by flooding the crop basin. So as all of us know, the soil contains 2 types of pores. One is micropores and second one is macropores. So the water held in the micropores only is available for the use of plants. And secondly, the soil contains 3 kinds of water. One is hygroscopic water, second one is capillary water, and third one is the gravitational water. So hygroscopic water means water that held tightly towards the surface of soil particle by the force of adhesion, which is also known as water of adhesion. And this water of adhesion is no way available to the use of plants. Even if you go for oven drying, you cannot remove the hygroscopic capacity or hygroscopic component of the soil. And if at all you want to separate hygroscopic component, you may have to go for some extraordinary techniques like infrared drying or so. But as soon as the soil is brought back to the normal ambient condition, automatically the hygroscopic capacity will be regained. So you cannot use or you cannot utilize this hygroscopic capacity. The second kind of water is water held in the micropores of the soil by the force of surface tension, which is known as capillary water. And the third one is water held in the macropores of the soil, which is also known as gravitational water or free water. Free water means that is free to be drained away in response to gravity. Now, out of these two kinds of pores and three kinds of water, the only water that is available for the use of plants is the water, capillary water, which is held in the micropores. And with respect to irrigation, soil has three conditions, three moisture conditions, which are referred to as soil moisture constants. Okay, suppose a plant continues to extract moisture. Finally, a stage will reach that the plant can no longer extract enough moisture. The plant can no longer extract enough moisture to meet its transpiration requirements, and it remains wilted unless water is added to the soil. So this point is known as permanent wilting point. Though the term is permanent wilting point, wilting is not permanent. The point is permanent. It's a permanent wilting point. Wilting is not permanent. Or permanent wilting point is not the death of the plants. It is the point where you can decide either to kill the plant or allow it to grow. So if you irrigate at PWP, permanent wilting point, the plant will grow. If you don't irrigate, the plant will dry. Okay. So now this is also referred to as the lower limit of available water to any crop from a particular soil. So it is a soil characteristic. So permanent wilting point is the lower limit of available water to any crop from a particular soil. Now, if we add water at PWP, initially all the micropores will be filled with water. And finally, a stage will reach that all the micropores are filled with water and macropores are empty. So this is referred to as field capacity. So field capacity means all the micropores are filled with water, or you can say the capillary water is only available plus hygroscopic, which is not available. So this field capacity is also referred to as the upper limit of available water. Okay. Again, if you add, all the pores will be filled with water, and then no void space will be left. This is known as saturation capacity. So in conventional method of irrigation, what farmers do is they add water to a dry soil. Initially, when it may be PWP, then it will become field capacity. Then again, they will add, that will become saturation capacity. Again, they'll start flooding in the basin. Then instead of, suppose you are irrigating banana requires 10 liters of water in precision farming. But a farmer who used to practice the conventional surface method of irrigation, like basin irrigation, so the irrigation interval may be once in 3 days, like that. So instead of giving 10 liters per day, the farmer may supply 100 liters within 3 days. But unfortunately, within few seconds, the excess water will be drained in response to gravity. So what happens is this applied water that moves down below the crop root zone, maybe it's percolate and depercolate, and finally it may advance towards the groundwater reservoir. Then the conventional method of fertilizer application is they will apply the fertilizer, solid fertilizer, which are all water soluble fertilizers. They will take a small trench around the basin, around the plants. Then they will they'll just apply the fertilizer, and just fill back the trench, and they will apply water. So this excess water during its transit towards the groundwater through the depercolation through the root zone, these water soluble chemical fertilizers applied also will be dissolved in this water, and that will be heading towards the groundwater table. And ultimately, all these, the applied nutrients plus whatever them pesticides or insects, whatever components available in the root zone, everything will be leached down, and finally that will advance towards the groundwater, and ultimately that will lead move to your water source. And ultimately, when you pump out from your wells, you may get these contaminants in your water, which you will consume from your kitchen through cooking. So ultimately, it spoils the soil, then water resources below the soil, the entire ecosystem, and health of human beings. So that's why it is referred to as the modern eco-friendly technology, because it reduces stress on natural resources. Secondly, if you apply the right input, the right quantity, the right place, and right time, obviously the quality of the produce will be extremely high. So you can ensure a better quality produce. So once a better quality produce is ensured, two more things are ensured, like marketability and market price. You can ensure a good market for the crop and a better price in the market. So because of these two reasons, the precision farming is referred to as modern eco-friendly technology. So as all of us know, we, the human being, the healthy, wealthy, wise human being, cannot even consume our 3-time meal in a single stretch, cannot even drink our whole day water in a single gulp. but what cruelty we are doing against the poor living creature known as plants. So the people in the conventional irrigation, we irrigate once in 3 days, we give fertilizer once in 2 months, and we are asking the crop to give back optimum yield. Because a plant needs water when it is thirsty. A plant needs nutrients when it is hungry. So you have to say, here comes the importance of precision agriculture, the right input, the right quantity, the right place, the right time. Now, what are the advantages or outcome of this technology? Increased profit and sustainability. You can ensure sustainable production, and obviously you can increase your profit. Improved product quality, effective and efficient pest management, pest and disease management, energy conservation, water conservation, and soil conservation. So what happens is, in the conventional surface method of irrigation, the maximum efficiency that you can expect is up to 30%. So minimum 70% of water is wasted in surface method of irrigation. So if you are wasting 70% of water, not only you are wasting 70% of water, then equivalent amount of power also, because all over the globe, we are facing acute power crisis and a more acute water crisis. So if you are adopting the conventional method of irrigation, you are simply wasting almost 70 to 75% of water and an equivalent amount of power. Also, you are spoiling your groundwater and surface water resources. So you can save your energy, you can save your soil, you can save water, as well as you can protect your surface and groundwater resources. Now, coming to the components of precision agriculture, the major component of precision agriculture is micro irrigation. So micro irrigation is nothing but precise daily application of water into the root zone of the crop in the form of fine droplets or spray. So precise daily application. So you have to apply water daily precisely into the root zone in the form of fine droplets or spray. So we can say micro irrigation is almost 50% of precision agriculture. The second major component is fertigation. Fertigation means precise periodic application of water soluble fertilizers along with irrigation water. So if you are applying water soluble, any fertilizer which is water soluble, you are applying along with the irrigation. So precise periodic application of water soluble fertilizers along with irrigation. So this is the second major component. So we can say 50% of precision farming is micro irrigation. Another 20% is fertigation. The third component is plastic mulching. Okay, so we are providing mulching so to prevent the evaporation loss from the crop root zone, also crop basin. So normally in conventional farming, people go for organic mulch. Organic mulch means the crop residue of your own field or your neighboring field. So this crop residue or residue of the previous crop that may contain bacteria, fungus, virus, all the disease carrying vectors. So in precision agriculture, we are practicing micro irrigation. Micro irrigation means you are applying water daily into the root zone. So the root zone is almost moist daily throughout. So you are using hybrid or high yielding variety. So the one disadvantage of the hybrid or high yielding variety is the pest and disease tolerance will be less when compared to the local cultivar. So you are using the hybrid or high yielding variety which is least resistant to pest and disease. You are applying water through micro irrigation. Every day you are irrigating and you are dumping this organic mulch in the root zone means, root basin means your entire crop may vanish within few days. So that's why you are not supposed to go for organic mulch. Instead, you have to go for plastic mulch. So in case of organic mulch, you got only one advantage or one objective of preventing the evaporation loss. Whereas in plastic mulching, you got 5 advantages. The first one is you can prevent the evaporation loss. Second thing, you can maintain the soil structure because under plastic mulch, soil is below a protective cover. So the outside weather is not adversely affected the soil structure. So soil structure you can very well maintain. The third one is you can regulate the soil temperature. Because for effective microbial activity in the root zone, some amount of temperature is essential, and this plastic mulch can ensure this temperature. And so it can prevent the evaporation loss, it can maintain the soil structure, it can regulate the soil temperature, and also it prevents the leaching of nutrients during heavy rainfall. During heavy rainfall, during monsoon season, what exactly happens is the nutrients or whatever things available in the root zone, it's washed and it's moved down. So it can prevent the leaching of nutrients during heavy rainfall. And the last one is completely eliminates the weed growth. Okay. So, but you have to just bear in mind, plastic mulching is the third component of precision agriculture. First one is micro irrigation, second one is fertigation. So, if there's a farmer who is not willing to go for micro irrigation, fertigation should not go for plastic mulching, because once you go for plastic mulching, the only way for applying irrigation and fertilizer, water and fertilizer, is micro irrigation, fertigation. So, the third component is plastic mulching, and fourth one is crop geometry. Crop geometry is nothing but maintaining optimum crop to crop and row to row spacing to accommodate maximum number of seedlings or seeds in the available space. So you have to exactly follow the maximum permissible crop to crop and row to row spacing for this particular variety, and you have to accommodate maximum number of seedlings, which is also referred to as high density planting. Then the fifth one, last one is integrated pest and disease management, IPDM. So all these five together is known as the entire scenario of precision agriculture. Now, irrigation management in precision farming. There is no other means than micro irrigation, fertigation, precision farming. Now, what is exactly micro irrigation? So, if your irrigation strategy, your irrigation method satisfies five characteristics, you can very well call it as micro irrigation. Water is applied at a low rate. Water is applied over a long period of time. Water is applied at frequent intervals. Water is applied near or into the plant root zone. And fifth one, water is applied through a low pressure delivery system. So any irrigation system which satisfies these five characteristics can be classified as micro irrigation. Unfortunately, our overhead sprinkling system, overhead sprinklers is not classified as or not coming under micro irrigation, because in sprinkler irrigation or overhead sprinkling, we are not satisfying three of these five characteristics. Water is not applied at a low rate, water is not applied into the root zone, but water is applied above the canopy, resembling something that of an artificial rainfall, and water is not applied to a low pressure, water is always applied at a high pressure, under high pressure. So overhead sprinkling is not micro irrigation. The commonly available micro irrigation systems are micro sprinklers. Micro sprinkler means small sprinklers which operate the same principle of sprinkling, then which applies water below the canopy in the root zone, around the plant root zone. So this is micro sprinklers. And second one is spray jet, just like a spray is coming off a spray bottle, very minute water droplets which are useful for irrigating orchid, anthurium, vanilla, etc. So especially for the vines. Then drip irrigation. Drip irrigation is the most popular micro irrigation system throughout the globe. And this was introduced to the globe by an Israeli engineer, Singa Blas, and who is also known as the father of drip irrigation. So drip irrigation, which is also referred to as trickle irrigation. Now, drip irrigation is nothing but you are exactly applying the water needed for the plant growth in the form of fine droplets into the root zone. So drip irrigation that minimizes or eliminates the conventional water loss like depercolation, surface runoff, and soil evaporation. So the irrigation efficiency is as high as more than 90% in drip irrigation. Now the advantages of drip irrigation is that increase the beneficial use of the available water. So minimum 2/3 of water you can save. So you need only 1/3 of the water that is needed by utilized in the that is applied in the surface method of irrigation. So in conventional method, if you are applying 100 liters, you need only 30 liters or 30 to 35 liters through drip irrigation. So enhanced plant growth and yield, retarded weed growth, improved application of fertilizers, and decreased energy requirement for the system, and reduced operational labor. And this is suitable for irrigating hilly terrains and problem soils. Now, these are the water application scenario under different irrigation methods. So in flood irrigation and sprinkler irrigation, the water is flooded around the root zone in the same manner. Only thing is that in sprinkler, the quantity is little bit less when compared to the surface or flood irrigation. But in case of drip irrigation, you can see a fixed line or a boundary is there. Whereas in sprinkler irrigation and flood method of irrigation, there is no boundary of application. So here, water is not exactly water. Moisture is held within a confined boundary. There is a fixed line. So just like a bulb like or a tuber like. So this is the exact volume that is needed, and soil moisture is always maintained at field capacity in drip irrigation. Now the components of the system, either a pump set or a overhead tank. Overhead tank means the tank should be located at a convenient height so that has to provide the required pressure. So for the operation of the drip emitter alone, maybe minimum 1 kg per centimeter square or 10 meters of water head is required. So sometimes now mostly your overhead tank will not be located at a considerable height, as you may not be able to go for drip irrigation with an overhead tank. In that case, obviously, you may have to go for a pumping system. So the pumping system, two things are highly essential. Your head and discharge requirement. So what exactly is the operating head required for the system, and what exactly is the discharge required? So selecting a pump based upon this is highly essential. Second major, so pump is known as head of the system. Head of the system is head controls the entire body, the head of the system. Second one is filters. Filters, there are two kinds of filters, and filters are also referred to as heart of the system. So just like head and heart are important for a human being, in a drip irrigation system, the pump set and filters, head and heart, which are equally important. So there are two kinds of filters, primary filters and secondary filters. Primary filters are used for the removal of solid impurities, whereas secondary filters is for micro impurities. So if the water contains sand particles, you may have to go for a hydrocyclone filter or a centrifugal filter, which is also referred to as a sand separator. So this is something like this. So then second one is gravel filter or a media filter. So a media filter means it's a sand filter. So a large container is filled with sand and water is applied through the tank. So you are filtering the suspended impurities using a filter. Then this first one and second one, which are the primary filter, which may not be essential always. That depends upon the water quality. Sometimes two primary filters, or sometimes one primary filter, or sometimes no primary filters required. So depending upon the water quality. Whereas secondary filters are highly essential. So earlier systems had screen filters, and the new systems having disc filters. This is for the removal of the fine impurities as well as the fertilizer induced impurities. So the configuration is like this. Just you have to go for the primary filters, one or two, then you have to go for the fertilizer application system, then the secondary filters. The new systems or latest systems are having only disc filters, no screen filters. Then the main line, 40 to 120 millimeter diameter pipes of high density polyethylene or PVC pipes, submains 25 to 50 millimeter high density polyethylene or PVC pipes, then laterals of 12 millimeter or 16 millimeter low density polyethylene or linear low density polyethylene. Then the emitters of 2 liters per hour, 4 liters per hour, and 8 liters per hour. Normally for the seasonal crops, 2 liters per hour emitters are used mostly for vegetables. So maybe one emitter of 2 liters per hour per plant. And for just like annual crops like banana, you may go for 2 emitters of 2 liters per hour. And for perennial crops, 8 liters per hour, 2 to 4 emitters. So that's depending upon the water requirement. Then other controlling and monitoring devices. So this is a dripper system. There are two kinds of emitter configuration. One is online drippers and second one is inline system. So this is an online system where the emitter is fixed on the lateral, and this is an inline system where the emitter is inside the lateral. The advantage of online system is it is so you can manage the spacing. So depending upon your crop requirement, you can just adjust. You can remove the online emitter. You can block it using a dummy emitter, and you can make the spacing. You can vary the spacing, and it is easy to clean the online system. Whereas in case of inline system, so you cannot change the spacing. It's a fixed spacing, as well as it is not easy to clean the system. Now, coming to the fertigation, it is a precise periodic application, so simultaneous application of water-soluble fertilizers. So it is a highly efficient method of fertilizer application that saves water, energy, and nutrients. So with drip irrigation, fertigation is not optional, but it is absolute necessity. So earlier we used to say with drip irrigation, there is an option for fertigation. But nowadays we are insisting that with drip irrigation, there is an absolute necessity for fertigation. Now this terminology evolved from this fertilization and irrigation, half of the fertilization, half of irrigation, fertigation. So this is conventional fertilizer application. You are simply applying at random without knowing the field variability. So this is the fertigation where the right input, right quantity, right place, right time. Now the advantage of fertigation like uniform application, placement exactly in the root zone, quick and convenient method, the most convenient and most quick method of water and fertilizer uptake in fertigation. Then it saves fertilizer, frequent application is possible, possibility of application of different stages and different nutrients depending upon the growth stage of the crop, and different nutrients, micronutrients as well as macronutrients, and it saves the groundwater from pollution. So there are three means for applying fertilizer. First one is venturi. Venturi is nothing but a sudden constriction in the diameter of a pipe. A continuously running pipe, if you are providing a sudden constriction, according to continuity equation, the area is reduced, so velocity is increased. Again, in a pipe flow, pressure in the velocity is a constant. So the pressure automatically reduces because of the increased velocity. So if you make a small hole and allow water which is kept in the atmospheric pressure, automatically it will be taken up. So this is the advantage of venturi. Venturi is the simplest of all fertigation devices, and the cost is very less, and it is simple, no moving parts. But the only thing is that if you are using venturi, considerable head loss may occur. So you may need another 10 to 15 meters of additional head, because 1 to 1.5 kg per additional pressure is 1 to 1.5 kg per centimeter square additional pressure is required in a venturi. So 10 to 15 meters of water. So if you are increasing, your head requirement is increased, automatically your power requirement of the pump set is increased, cost of the pump is increased, and operating cost of the pump, the current bill, energy bill is also increased. Whereas if you go for a fertilizer injection system or fertilizer injectors, fertilizer pump, it's a hydraulic pump, zero energy pump. So no additional cost is, no additional head is incurred. So no additional no additional head is incurred. No additional horsepower is incurred, so cost of the pump and the cost of pumping can be reduced. But the cost of this fertilizer injector is almost 5 times that of a venturi. And the third option is a fertilizer tank. So this has considerable head loss as well as it fetches considerable amount of cost. But you are not supposed to use a fertilizer tank, because in case of fertilizer injector or venturi, in both cases, you are simultaneously applying the fertilizer solution to move through the system by keeping it in an open container. Whereas in fertilizer tank, you are simply filling the fertilizer solution into the tank, you are closing it and you are allowing water to move through the tank. So what happens is at every second there is a dilution of concentration happening in the tank. So non-uniform, highly non-uniform application of fertilizer in fertilizer tank. So you are not supposed to use a fertilizer tank, either a vengery or a fertilizer injection system. Now, in drip fertigation, for an effective crop growth, not only moisture or water is required. So a crop that requires moisture, presence of nutrients, and soil aeration. So all these three are ensured only through drip fertigation technology. That is why precision farming that gives better yield and growth. Now the third component, we already explained, the plastic mulching. It is after installation of the drip system only you have to go for a plastic mulching. So after taking the bed, after laying the laterals, you have to spread that mulch sheet, you have to anchor it at the ends, and you have to make the holes with a special punching device, and you have to sow the seeds or seedlings. So this is an 100% precision farming scenario.
Excuse me, Dr. Hakim, I'm sorry, but your presentation time is up.
Yes, I'm finishing. I'm going to the last slide. So okay, so these are the advantages of the plastic mulching. So I already explained some of the photographs of plastic mulching. So I just want to conclude with this, that the precision farming is the future of food security, the future of water conservation, and future of energy conservation. So thank you.